Hello and welcome back. So today we'll be looking at another type of question based on trigonometric ratio of multiple angle, and in this question we're going to take the left hand side of this equation and try to solve for our right hand side, which is 3 by 2. So at first let me take the left hand side. So this is my left hand side of the equation. I've copied the same expression. Now what I'm going to do is just a simple rearrangement here. At first I'm going to bring cos to the power 4 7 pi by 8 right over here to make my second expression, and then I'm going to copy the remaining term as it is. So cos to the power 3 pi by 8 and cos to the power 5 pi by 8. Now I'm going to use the formula. I'm going to use a simple trick, not a formula, just a simple trick to change this 7 pi by 8 in terms of pi by 8. So what we can do is we can write pi minus pi by 8 for 7 pi by 8 as pi minus pi by 8. If we take the LCM, then here we have 8 and 8 pi minus, and then pi leads us to 7 pi by 8. So for 7 pi by 8 we can write pi minus pi by 8. I hope it's clear. Similarly, what I can do here is I'm gonna write cos to the power 4 3 pi by 8 as it is, and I'm gonna change 5 pi by 8 in terms of 3 pi by 8. So for that I can write 5 pi by 8 as pi minus 3 pi by 8. So this leads us to 5 pi by 8. You can check it yourself. Now one more thing I'm going to use here is for this we can write cos pi minus pi by 8 and then the whole power 4, but what we know is cos pi minus pi by 8, or say cos pi minus theta. Theta is any angle, so cos pi minus theta is equal to negative of cos theta. So we can write cos pi minus theta as minus cos theta. It's just a simple quadrant rule, or you can say a formula I'm going to use. So this formula I'm going to apply over here, and you can see the result. So for this term, cos pi minus pi by 8, what I can write is minus of cos pi by 8 to the power 4 is as it is. And one more thing, we have negative sign over here and we have the power 4. So if we have any negative term to the power 4, then we can write this as the negative sign changes into positive and x to the power 4. So we can write this way. So instead of writing negative cos pi by 8 to the power 4, what I'm going to do is I'm going to erase this and write cos to the power 4 and then pi by 8. I hope it's clear to you. If you have any confusion, you can mention it in comment section, and I'm gonna find the solution for you. For this cos to the power 4 3 pi by 8, I'm gonna write it as it is. And for this, if I apply the same rule as I applied for this expression right over here, what I get is cos to the power 4 and then 3 pi by 8. You could try it by yourself. Now we have the two expressions same, cos to the power 4 8 pi by 8 and then cos to the power 4 pi by 8. If we sum this together, then we have 2 cos to the power 4 pi by 8, and here also we have 2 cos to the power 4 and then 3 pi by 8. Now what I'm gonna do is I'm going to take 2 common, and inside the parenthesis I have cos to the power 4 pi by 8 and then cos to the power 4 and then 3 pi by 8. Once again, I'm going to apply a simple trick right over here. So I'm gonna write 4 1 by 2 times 4, and then the remaining term I'm gonna write it as it is, cos to the power 4 and then 3 pi by 8. Now I'm going to distribute this 4 for both expression inside the parentheses. After that we have 4 cos to the power 4 and then pi by 8 and then 4 cos to the power 4 and 3 pi by 8. Once again what we can do is we can write this term as 2 cos squared pi by 8 and then we have the whole power 2 or whole squared, and we can do the same for this term 2 cos squared and then 3 pi by 8 and then the whole squared term we have here. Now I'm going to apply the formula for this term, which is 2 cos squared pi by 8. If we look closely, then we can apply the formula for this term. It is same as 2 cos squared theta, so we can change this in terms of cos 2 theta and we have the formula. So here we have the formula. Cos 2 theta is equal to 2 cos squared theta plus 1, so we can write 2 cos squared theta is equal to cos 2 theta plus 1. So I'm going to apply the same formula over there. So what I can do is I have 1 by 2, and for this term right over here I'm going to write cos 2 theta is pi by 8 cos 2 theta plus 1, and then we have whole square term here, and I'm going to apply the same formula for this term 2 cos squared theta. So we have cos 2 and then our theta is 3 pi by 8 plus 1, and then we have the whole square term. Now we can simply cancel 2 and 4 and we can write here 4 2 4 1 by 2. So cos pi by 4 is definitely cos 45. So we have to apply the table value for cos pi by 4, which is 1 by root 2 plus 1, and then we have the whole square term here. And then cos 3 pi by 4 is, of course, we have the table value of negative 1 by 2, and then we have plus 1, and then the whole square term. Now once again we're going to apply a formula here. This is the formula for a plus b whole squared, so it is in the form of a plus b whole squared, and we have the formula a squared, which is 1 by root 2 whole squared, which is 1 by 2. A squared plus 2 times a is 1 by 2, b is 1, and b squared is 1 squared, which is of course 1. And then once again we have the formula for a plus b whole squared. A squared is 1 by 2, and then plus 2 times a is negative 1 by 2 root 2, and then times 1 and plus 1. Now finally we can see that we can cancel these 2 times 1 by root 2 terms, and then here negative 2 pi root 2 terms, so these 2 terms we can cancel out, and the remaining term what we have is 1 by 2 plus 1, and then here 1 by 2 and then plus 1. So we have 1 by 2, 1 by 2 and 1 by 2 is 1, so 1 plus 1 plus 1 is 3, so this leads us to 3 by 2, which is our right hand side of the equation. So this is what we have to prove. It's quite simple. We just apply two formula here, and I hope it's clear to you. And yes, thanks for watching.